All right, let's do the example with a rational function. So let's say x goes to, let's say 2 again. I apparently like the 2. And then I'm going to do a, let's do an x minus 2 here. And the reason why I chose those numbers is because if you look at what's going to happen when I evaluate it at x equals to 2, I get 1 over 2 plus 2 minus 1/4 divided by 2 minus 2. So when you look at what you have there, you have 1/4 minus 1/4 is a 0, divided by 2 minus 2, 0 again. So yeah, you want to factor, but first you want to do some common denominator here because you have fractions. Whenever you have fractions, you want common denominators. So let's go ahead and see what happens here. Another thing I'm going to do before doing the common denominator, or in the same line if you will, I'm going to grab this x minus 2. I'm dividing by it. I'm just going to multiply times the reciprocal. That is just so it doesn't get too crowded. And so I'm going to go ahead and write this right here. And then I'm going to do my common denominator. So I decided against doing it in the same line for the sake of clarity. So let's go ahead and now do our common denominator. Copy our x minus 2 here. Common denominator, I get 4 times 1. Let's do my cross multiplication. Minus 1 times x plus 2 divided by the product 4 times x plus 2. So this is just cross multiplying and then the product of the denominators. Your common denominator formula right there. All right, so here I'm going to do a little bit of algebra. And in this particular case, things will cancel right away after I factor. Actually, I have to factor just a -1 out of that. Let's go ahead and operate it. So I get 4 minus x minus 2 divided by 4 times x plus 2. Ooh, I dropped the 2 there. I guess I was hungry. Ate it. All right, so now here, copy everything, times, I'm going to have 4 minus 2, which is 2, minus x. I ate a parenthesis there. Wow. There you go. 4 times x plus 2. All right, so now this is where you need to factor. I finally got to the factoring. And in this particular case, it's nothing too big. Notice that x, I'm going to write it here as a comment, x minus 2 is going to be equal to negative 2 minus x. Alternatively, 2 minus x is going to be the negative of x minus 2. To confirm this, just distribute the negative. You get negative 2, negative, negative, plus x. So when you have that, you can either rewrite this one, which is what I did, or you can rewrite this one. I suppose I'm going to do the one that I already wrote. So I'm going to have the negative of 2 minus x. That minus looks a little interesting. Times 2 minus x over 4 times x plus 2. And now you see that the 2 minus x cancels. By the way, I already did this, this, and cancel the problem. By canceling the problem, what I meant is cancel the 0. You see, every time I'm computing my limits, I'm canceling a 0. And hopefully avoid the problem altogether. So far, that's been the case. Here I get the negative, I'm going to put it outside. In the numerator, I just have a 1. Denominator, I have a 4 times x plus 2. And at this point, you see there's no 0 over 0 when you evaluate for your second time. You just plug it in. Let's put it here. Negative 1 over, and then 4 times 2 plus 2, which is going to be 4. So I get negative 1/16. So negative 1/16 is the answer for this problem. All right, guys, so let's do the last example for today. So let's say we're going to do limit as x goes to 5. Let's do something else other than 2 for once. So let's do, for example, here, square root of x plus 20, for example, minus, and then I'm going to have a 5 here, over and x minus 5. So now you have a square root. Let's first plug it in just to make sure that we didn't get lucky. Maybe we got lucky and I wrote the problem correctly and, you know, that's it. But in this particular case, we plug in 5 minus 5 over 5 minus 5. And you see here I get a 25. Square root of 25 is 5. 5 minus 5 is 0. 5 minus 5 is 0 again. And I want to factor. And this one is a bit of a lie, because when you have a radical, you kind of want to do a multiply times the conjugate rather than factoring. At the end of the day, you may have to do some factoring, but this is the crucial step. You do want to multiply and divide by the conjugate. That doesn't affect the limit because you are multiplying and dividing by a quantity that is non-zero, so you're getting multiplying times 1, which then doesn't affect this factor here. So multiplying times 1 in a clever way, let's say. All right, so but what is the clever part of this is that here, if you call your quantity square root of x plus 20, you call it a, and b is equal to 5. What you have in the numerator here is going to be an a minus b. A minus b. And on the other numerator, you have a plus b. But that's going to be a squared minus b squared, as you know, is a difference of squares. And what that will do is you're going to have the square of a. That's going to be the square of this square root. Just cancels. Minus 5 squared. B squared is 5 squared, which is 25. And it's going to give you an x minus 5 there. You see, you're going to get from this big thing here, you're going to get an x minus 5. That will go in the numerator, and we'll cancel with this x minus 5 in the denominator. So let's plug that in, and you see how we're going to, after doing a little bit of algebra, we're going to, let's call this the step 2. We're going to cancel the problem, which is a good thing. So by copying this a squared minus b squared, putting it here, we get the square of the first, x plus 20, minus the square of the second, minus 25, which gave me x minus 5. All over x minus 5 times now the square root of x plus 20 plus 5. And that allows me then to cancel the problem. And I get that this limit, I can compute it now because I won't have any problems there in the denominator. It's going to be the limit as x goes to 5 of, and I'm going to have a 1 for the numerator, and the square root x plus 20 plus 5. Now you can see that if I plug x equals to 5, I get the square root of 25, which is 5, plus 5, no problem there. This is a 5, 1/10. And that's how you solve these kinds of problems where you have a radical. So we went through a radical, we went through a rational expression, and some polynomial. And I think that gives us a good idea as to how to compute limits analytically. There will be more, but we will do those when we look at computing limits or the derivative by definition. So we'll get to those as well. But for now, I think that's good. All right, see you next time.